Hi, thanks and welcome to this channel, and thanks for viewing this video. In the previous video, I talked about the order of precedence and how they are applied with arithmetic expressions in Java. In this video, I will talk about the three types of arithmetic expressions that there are. So first of all, let me start by defining what is an expression. An expression in programming language is a syntactic entity that may be evaluated in order to determine its value. So in programming language in general, this is how you can define an expression. And we can also keep in mind that there are various kinds of expressions in programming. We can talk of Boolean expressions, which is consisted of Boolean variables. We have character expressions, and we also have arithmetic expressions. So an arithmetic expression is an expression that consists of numeric values. So it's an expression that is made up of numbers. It can be decimal number, or it can be integral number, or real numbers. So we're going to be talking about arithmetic expressions in this video, and we will be talking about the three types of arithmetic expressions that we can find in programming and in Java particularly. So the first type of arithmetic expressions will be the integral expression. So an integral expression is when all operands in the operation are integers or real numbers. So like the example we have on the screen here, the system that we want to output the result of this expression, 9 plus 10 minus 5. So this expression is made up of real numbers or integral numbers, because they are not decimal numbers, as we can see here. So in this kind of expression, what we have to also note that is that when we evaluate integral expressions, the results will always be an integral number. For example, these expressions, if I run it in my console, you will see that I will have an integral number here, a real number. So that's, we had 9 plus 10, which is 19, minus 5 gives us 14. And this is an integer because we are dealing with an integral expression. So that's would be pretty much the same thing. For example, if I had an expression here and I said integer a, for example, and initialize it by giving it the value of 5, and b, I give it the value of 9, for example, and in my system.out that print line here, I say that I want to have an expression that says a times b and divided by 5 here. Or let me say divided by 2. Okay, so according to the order of precedence, so this expression is going to evaluate from the left to the right, because the multiplication and the division, they have the same level of precedence. So from the left to the right, that means that we'll have 5 times 9, because the value stored in A is 5 and the value stored in B is 9, which is going to give us 45, and then 45 is going to be divided by 2. But you will see that if I run this expression, I will not get a decimal number, but I will rather get an integer, a real number. Yes, so I am having a real number here. Why? Because all the operands here A, B, and 2, they are all real numbers. They are all integers. So this is what we have to remember about integral expression. So an integral expression is an expression which is made up of only integers and or real numbers. The second type of arithmetic expression is what we call the floating point expression. So going from the same logic, like the integral expression, so the floating point expression is a kind of expression which is made up of only floating point numbers or decimal numbers. Okay, so I would get a value like this, 5.4, for example, and 9.5. And so I need to change the data type. The data type I have to give the floating point data type, or I can give it a double as data type and then divide it by 2.2. So you will see that when I evaluate this expression, I will get a floating point number. Or floating point number is a decimal number. All right. Why am I getting a floating point number? Is because that expression is made up of only floating point numbers or decimal numbers. So it's the same thing. So a floating point expression is made up of floating point numbers or decimal numbers. And when evaluating a floating point expression, the result will always give us a floating point number. So that's pretty much it. And then the last type of expression is what we call the mixed expression. So a mixed expression is an expression which is made up of both integers and decimal numbers. So in a single expression, you will have decimal numbers and floating point numbers. So let me give an example. Let me take a quick example. I can have something like 7 divided by 3 plus 4.8 as an expression. So this is my expression. And in this expression, I'm having 7, which is an integer, 3, which is an integer, but I also have 4.8, which is an integer. So in Java, it is possible to have these kind of expressions, arithmetic expressions, where we have operands which are of different data types. So we have integers, and then we have here floating point and decimal numbers. So now the question will be to know, how does a mixed expression evaluate? How does it evaluate? Which result are we definitely going to get when we try to evaluate a mixed expression? So here we have to follow 2 rules. The first rule is related to the order of precedence that we saw in the previous video, which says that the multiplication, the division, the modulus operators have the same level of precedence. The addition and the subtraction also have the same level of precedence. And which also says that the multiplication, the division, and the modulus have a higher level of precedence over the addition and the subtraction operator. And it also says that for the operators that have the same level of precedence, we evaluate an expression from the left to the right. So even with mixed expressions, the order of precedence remains the same, even with mixed expressions. But it also has to respect another rule, another set of rule, which is in the case, for example, like in this expression that we have here on the screen, 7 divided by 3 plus 4.8 here, these expressions, how to for example, in this order of precedence, we were going to get like 7 divided by 3 is going to give us 2, because these two are integers. Okay. And if they are integers, okay, let me give a very simple example. So in this expression, I have 2 plus 4.8. So this is an expression in which it's a mixed expressions. We have an integer and then a decimal number. So the first rule that it applies here is that if the operands of an operator are of different data types, which means that one is an integer and the other one is a floating point, when calculating, the integer number will have to be treated as a floating point number. Okay, and its decimal part will be 0. So that means that when calculating this, when evaluating this expression, the number 2 is going to be treated as a floating point number, as a decimal number, even though it's an integer. Okay, so it's just like basic mathematics. We know that in mathematics, when we have real numbers like this, in reality, they are decimal numbers, but the decimal part of these numbers is actually 0. It's just like we are writing 2.0 here. So 2.0 is the same thing like writing 2. So this is what is taken into account when evaluating a mixed expression. So in this expression, when we evaluate, 2 is going to be treated as 2.0, and it's going to be added to 4.8. So, and this will necessarily mean that the result that we're going to get is going to be a floating point number or a decimal number, because be it an integer is going to be treated as a decimal number, and the decimal number is basically also going to be treated as a decimal number. So if I round this, you will see that I will get 6.8. Okay, like even if I put I put minus here, let me say 9 minus 2 here, you will see that I will always get a decimal number. So this is going to be evaluated first because of the order of precedence. After evaluating it, it's going to give us an integer, and that integer is going to be added to 4.8, which is giving us 11.8. So in the mixed expression, if you have you are evaluating an integer with a floating point number, we have to keep in mind that the integer is simply going to be treated as a floating point number, and its decimal part will be equal to 0. And the result we will get is going to be a floating point number. You know, the result is going to be of a data type of a floating point. So this is it. And like if we have in this expression here, we are having multiple operators. We have the minus, we have the addition here. With 9 minus 2, there's nothing which is going to happen because the two values are integers. So if we run these two values, we'll still get an integer. So there's nothing to say about it. But that integer, if we add it to a floating point number, then that's where we're going to apply that rule where the integer needs to be treated as a floating point number. So we can have multiple expressions where we're going to mix integers and floating point numbers, and you will definitely see that the result is going to be floating point numbers. 15 divided by 2 plus this is just an example that I want to add. 9 times 2 4.1. So this, if I just run it, you will see the result I'm getting. So these are all floating point numbers. So it's still respecting the order of precedence. Like here, we could see 9 minus 2 is 7. 7 plus 4.8 is 11. 11.8 here. So the order of precedence is still respected. Even here, 9 times 2 is 18, and divided by 4.1, it gives us this value here. So the order of precedence is still respected, but when it comes to evaluating an expression or an operation where one operand is an integer and the other one is a floating point number, so the integer is definitely treated temporarily as a floating point number, and then the result out of that operation is going to be a floating point of a floating point data type. So I hope this has been informative, and that's what I wanted to talk about concerning 3 types of arithmetic expressions. Thanks for viewing this video, and let's meet in the next video. Thanks a lot.